we're going to walk through sort of how to install and work around in the Arduino IDE. So I would recommend, if you can, have your laptops out and ready so that you can sort of follow along and install the IDE as we go through this. All right, so an IDE, like I mentioned previously, is called an integrated development environment, right? It is software that helps you write programs. So it has a few tools built into it. It's going to have your compiler. It's going to have a source code editor, which is basically a text editor, but it'll usually do some markup for you, like it'll do color coding of, hey, this is a variable, oh, this is a function declaration that makes it easier to see. And often it'll include a debugger that will help you figure out what the issue is when your code doesn't work. So source code is, the readable code written out in text that the compiler will then convert into machine code, right? That's the actual low-level binary instructions for a computer or microcontroller that tells it what it needs to do without additional translation. Right, so all of your things are going to include a text editor, which is your source code editor. In theory, I could write all of my Arduino code in like Windows Notepad. I could open it up and I could just type everything in there, right? But it's nice to use something that is meant for editing code, because it'll do things like it will highlight variable types. It will automatically indent after you create a new function. It will highlight the opening and closing braces that match each other, right? Some source code will actually use auto completion. So it'll like use tab completion. If you have like named a variable, you can start to type the name in and hit tab and it'll finish it. Unfortunately, the Arduino IDE does not do that. The next thing, part of the IDE, is the compiler, right? It's what converts the source code, in this case, to the machine language, right? It compiles the instructions from what you've written in. And then the debugger helps you test and figure out where the errors are in your code. Often what will happen is you'll think you'll write some code and you'll try and compile it and you'll get an error. And on Arduino, it's on the very bottom. It's the little black and orange text. And it will hopefully give you some error message that helps you figure out what the error is. So there's all kinds of IDEs. Obviously, for the Arduino programming we do in this course, we're going to use the Arduino IDE. Visual Studio is Microsoft's, set of IDE. There are so many different IDEs. This is just a list. Everyone has their own preferences, and obviously some of these are specific to different languages. Okay, so here is the URL that you guys want to go to download the software, right? And I would imagine most everybody's using either Windows or Mac, but there is also Linux versions. So when you get to there, you should see a link to download the IDE that looks something like this, right? And you're going to see different versions. So you're going to see a Windows installer, this Windows app, a Mac version, and then the Linux versions. So you're going to want to download the appropriate one for whatever platform you're using. Now, I will say, for those of you on Windows, don't download this Windows app. This is like the version for the like Windows 8, Windows 10 App Store that Microsoft tried to make like the Apple App Store and then gave up like 3 or 4 years ago. So don't get that version, just use the installer version. Everyone else, just download the appropriate version for your platform, and then it's going to install, it's going to open a install wizard. You're going to run through the normal, hey, this is where I want it to install. These are the shortcuts. Make sure you install the USB driver when you do that, right, as well. So once you get through that, you should have a shortcut. You should be able to open up the Arduino IDE after you've installed. It'll open up a new blank sketch that will have this setup and loop. It's going to give this sketch a name based on the date. And it's going to create this in a folder that it calls the sketchbook folder. On Windows, that's by default in your documents drive. But you can change that in the preferences. So a few things to note inside the IDE. So you got this toolbar at the top. You got with your file, edit, sketch, tools, and help menu. These icons below there, that is actually your shortcuts for verify or compile. So that's just going to compile the code. Upload will actually compile the code and then upload it to the connected Arduino. And then you have icons for a new sketch, say open a sketch and save the current sketch. I don't know why they decided to not use the standard, folder and disk for open and save. They used an up and down arrow. Unfortunately, I think that's a little confusing, but that's what they did. So this magnifying glass up in the corner is the serial monitor. You can also get to it from the tools menu, but that'll pop up another window where you can then, monitor your serial port to get the output from your Arduino. So if you open the file menu, you'll see the obvious options: save, new, open. It has that open recent, which will have something like, I think, like your last 10 sketches. If you click on that sketchbook, it will open, it'll show a list of basically all the sketches within your folder. What can be really useful is that examples. So that's going to have examples from all of your installed libraries. So that's useful for getting examples of how to do specific tasks using various libraries. So it's going to have a bunch of real basic examples that come pre-installed. And as you add additional libraries, there will be more examples that show up below this. So one thing to note is on this file menu, there is a preferences. That's where you can change a few options. In particular, many people like to turn on the display line numbers option, right? Which is gonna turn on all of your line numbers. You can also change the sketchbook folder in the preferences. This is basically your main options of what you want to change. In particular, I will point out is there is this save when verifying or uploading. So that will save and possibly overwrite old code if it's enabled. So that's something you may want to turn off. There's a few options within this edit menu. Mainly, I think the main most useful one is changing the font size. You can also copy and paste from here. Control C, Control V, I think most people are familiar with. Yep. There's also an option here where you can basically select a whole bunch of text and comment it, but okay, so the sketch is where your menu for doing stuff like compiling, uploading. You don't often need to use the upload using programmer. We won't use it here, but you can basically have an external programmer that will there's a programmer built onto the Mega board that takes the signals that get sent through the USB and converts them up to the appropriate form for the code for the actual microcontroller. And it's possible to do that with an external piece of hardware as well on some Arduino boards. So that's what that option's for. Exporting the compiled binary is what takes that actual compiled machine code, and you can get the actual file on there. Normally that isn't saved, and it's not often that you need a copy of that file on your laptop or whatever machine you're using to program. So like I said, there's a difference between verifying and uploading. Verifying just checks your code for errors. Uploading actually sends it to the microcontroller. A lot of times it's best to verify until you made sure you've gotten all of your errors out, because it'll be faster than trying to upload every single time. So one thing that we're quickly going to run into is using libraries, right? So a library is some externally defined set of code that has like predefined functions, right? So the way that you include libraries is you use this include statement with the name of the library. So right here, we've included a library called pitches.h. And you can actually do this from the sketch menu. So if I select this include library, and it'll then list all of my installed libraries, and I can click on them and it'll add this line to the top of my code, which is something that can be quite useful, and make sure you don't have a typo in the name of the library. So there are a few gotchas with these libraries because they're actually stored a few different places. All of the default libraries are within the actual install library. So that's the stuff that comes with the IDE. That's going to be stuff like your SPI library, the wire library, which is used for I2C, the serial, that's all in there. When you install user libraries, so like libraries you manually download from somewhere, it's going to go inside that sketchbook folder, right? There will be a folder called libraries, and then it'll go there. So like I said before, in particular on Windows, that defaults to a folder called, within the documents folder called Arduino. And then you can see there's all these libraries installed here. And you can change that option within the preferences menu. You can use there's a library manager built into the IDE. So if I go to the sketch and I hit include library, the very first option is going to be called manage libraries. And it's going to pop up an external window that's going to basically list a bunch of libraries and have a little search window in here. So I can type a partial name and search, and then it'll give me a list of the libraries, and then I can hit install, and it'll actually install that library into that user library folder that I just showed. And that's nice because that will actually check for the most recent version. It'll automatically put it in the right spot. Now, one thing to be careful of is, especially if you are manually installing libraries, which is another way you can do it, is I can just copy the library folder into that libraries folder. So if you're doing that, one thing you got to watch out for is the name of the folder has to match the name of the .h header file. So if I have a folder that I downloaded the library, it had the name sd-master, but the actual header file, the sd.h file, is called sd.h. That won't work. I have to actually rename that SD master folder to just SD. And then finally, the thing is libraries inside that sketchbook folder that you give the same name as pre-installed libraries are going to override the default libraries. It's going to load those preferentially. So under tools, this is mainly where you are going to select the port for the serial monitor. You're going to make sure that you have the correct Arduino board and processor selected. Most of the times it's going to automatically select that correctly, but not always, particularly if you're switching back and forth between different boards. So like I said, there's a whole bunch of different Arduino boards, and the IDE needs to basically know which version of hardware you're using so that you can properly compile and upload your code. So you'll see this board option here and a processor. So we're going to be on this Arduino Genuino Mega or Mega 2560 board, and the AT Mega 2560, right, are the ones we want selected. And you can also see here under the tools, I can bring up my serial monitor. It also has this serial plotter where it will sort of automatically generate a time plot based on values that you send over the serial monitor. But you have to format them a very particular way. So that could be useful if you're trying to do live monitoring of some variable value, but often it's just easiest to do the text. And then you can use this get board info to get the information about the Arduino that is currently connected on the USB port. So, like I said, one thing that you may have to do is you'll have to select the appropriate COM port under this port menu option. So usually there will only be the one COM port available, and you just have to click it. But for some reason, sometimes it doesn't automatically switch to that. So you'll try and upload the code, you'll get an error, and then you'll just have to go click this. And even though there's only the single option, right, you have to manually go in and click it, unfortunately. And then, there is a help menu. Usually, what's most useful is to start looking on the Arduino forums, or obviously ask your instructor or me if you're having an issue. So like I said, one thing that's really important with the serial monitor is you got to match the baud rate. So if you remember, when we create this serial object, we give it this baud rate. And then if you can see here, the serial monitor has a little drop-down menu for us to select, and it needs to be the same. Otherwise, you basically get this, you'll get a bunch of gibberish, as opposed to this nice, clean, obvious set of numbers. The debugger is normally on the very bottom. It's this orange and black section. You can drag it up to make it bigger, but this is where the IDE is going to give you any errors and warnings. So often if something goes wrong, you'll need to drag this up, make it bigger so you can actually read it. So like we said, every sketch starts with these two basic parts. You have the setup and you have the loop. The setup runs once when the Arduino is started, whereas the loop will repeatedly execute. And one thing to remember is once you have uploaded this code to the microcontroller, to the Arduino, it's going to do this every single time you power it up, regardless of whether or not you have it connected to your USB, whether or not you have the IDE open or the serial monitor open. Once that code gets uploaded, as soon as the Arduino gets powered some way, it could be through the barrel plug, through the VIN, and have nothing on the USB, it will start executing this code, assuming that it uploaded correctly. So the most basic sort of things you declare is your global variables. You have these global declarations. You include your libraries, and you define these global variables that are accessible everywhere, right? And this is not any particular example right now. This is just showing you, yep, this is what a library declaration and global variables look like. So you put all of your stuff that only needs to be run once at the beginning in your setup. So like for a real simple example, this is where we would declare our baud rate. And, like, hey, in this example, we're initializing an SD card and doing a simple check to see if that worked, right? And writing an error message. We don't need to do that every single time we go through the loop. We only need to do that when we first power up. So we put this all in the setup. So the loop is where the main body of your code goes. This is where the stuff that you're going to be doing over and over again. So for example, this is where you're reading a sensor you would put that within the loop. So that's just sort of the very basics of, the navigating the IDE. Again, troubleshooting, always look for missing semicolons. That's probably the most common error and why something won't compile. Make sure your libraries are properly included and installed. Also be aware of some libraries may have conflicts with each other. Libraries often declare variables inside themselves. So if you have two libraries that are using a common variable name, they could run into issues. That's not super common though. Also, you want to make sure you got the correct baud rate. Variable names are case sensitive in Arduino. So upper and lower case makes a difference. Make sure you're using the correct data type. And that is it. Yes, go ahead.
Is the void function similar to the main function?
Yes, the loop function is very similar to a main function in other languages, yes. But with the key difference in other languages, the main function is not going to automatically repeat, whereas in this, the loop will repeat. So once it gets down to the bottom, it will go back to the beginning of the loop and begin re-executing that. So usually if you have a definitive end, like you want it to get to a point and stop, you prevent the loop from re-executing by preventing it from ever finishing. So you would, like, for example, start an infinite while loop that does nothing. That's often what you have to do with an Arduino.
Do we have to write like a for loop? Like what kind of loop is this?
So we will, so the actual void loop is a loop that will always execute. It will always go, once it gets to the end, it will always go to the beginning. As far as other intentional loops, like for loops, while loops, you know, we're gonna, yeah, you'll use those as you want in your own code.